Hi everyone, thanks for tuning in again. So today I'm gonna do a new kind of experiment here with something that I've been meaning to get into. I purchased myself the Turing Pi. You see it over here? So this is a board that you can use to cluster 7 computers. See the expansion slots there? Each one of those is meant to host a Raspberry Pi compute module, like the one that I have over here. And you can run 7 of them. And this is incredibly cool because the Turing Pi is sold as a cheap and easy to use alternative to running a cluster, which can be complicated in actual practice if you're running it in a data center. All of these does the networking for you so you don't have to, right? And also it's intended to work out of the box with a lot of newfangled fun things, specifically Kubernetes, which is something that I may have mentioned before and that I have worked with before, and that, it's causing a lot of buzz in the industry. Why? Because it's sort of this commonly accepted way to run distributed applications if you're into containers and all that fun stuff. So today I'm gonna install the cluster. I have seven of these little thingies here, so I'm gonna flash the operating system into them, and I'm gonna run a cluster where I'm gonna install Kubernetes. So it's gonna be fun. Let's get started. Alright, so this is how the compute module looks. This is a compute module 3, so it matches the technical specifications of a Raspberry Pi 3, right? So it's kind of like the compute only, without the bells and whistles, without the interfaces and ports and all that. So this is just an autonomous computer that you can plug into a cluster, right? And all 7 of these that I have are gonna go into the board. So let's install them. Alright, turns out that to use flash mode, you have to plug the compute module to the first slot from the bottom, actually. So this is how it's gonna look for now. My compute modules are the kind that have integrated memory. There's a kind where you can actually use micro SD cards with it, but I'm not gonna bother with that. I'm just gonna use the ones that I have. So I connected it here, and then these jumpers have to look like this. You have to change the jumper, otherwise the board won't go into flash mode, okay? So once you have that, just plug in your Turing Pi board, plug it into your computer, and power on the unit. The power supply is a generic 12 volt 5 amp power supply, so they should be pretty inexpensive. You can get them like anywhere online, right? So just plug it in, you should be ready to go. Okay, so if you plugged in everything correctly and you're in boot mode by setting the jumpers the way that I mentioned, if you take a look at the device manager or your system report on Mac, and if you take a look at the USB devices, as long as you have a device starting with BCM, that means that you're good to go. That means that you're on the right track. Now we need to run PLAYBOOK, which is a tool that you can download from GitHub. So now that the module is flashing, it's gonna take a little bit. Once it finishes flashing, we should be able to boot from it as if it was your regular run-of-the-mill Linux computer. You can just run SSH into it, do anything that you would like to it, And I'm gonna install Kubernetes next. But first of all, this is gonna take a little bit of time because I'm gonna have to flash all 7 of the modules, I guess. So just bear with me. Okay, so all 7 of these are flashed now. So now that everything is flashed, I'm gonna reset the jumpers back to the original position, like this. And it should go back to boot mode. Alright, check it out. Back to the original position. So I'm going to leave that plugged in. I'm going to boot it up. And bingo. So the Turing Pi has interfaces, so you can actually plug in your keyboard or your HDMI for your monitor and all that good stuff. You can plug it in there. As you may notice, it has networking. That's where you plug it into your network so you can run your cluster remotely, which is what I'm gonna do in a bit. Yeah, but see, this is nice and dandy. It's coming up. Life is good. All right. Finally, to finish the job, I'm gonna use what's known as an ANSIBLE playbook that's available on GitHub for a version of Kubernetes called K3s instead of K8s, right? What's the problem is that Kubernetes usually only runs on beefier servers than this. So the Raspberry Pi can definitely stand up a Kubernetes cluster, but you need a more streamlined version of it without all of the bells and whistles, so it actually makes it justice, right? So for that, K3s seems to be a popular option somehow. And I took a look at it. It works really straightforwardly. So, and with Ansible, Ansible does a lot of the legwork, so you don't have to, right? So Ansible is similar to orchestrators like Chef or Capistrano, and it's a way basically to specify exactly what you want to happen with cloud infrastructure, so you can make everything very generic. Just apply the same recipe as to how to prepare a server for something many times over. And you do it through something that's known as a playbook. So for convenience, I'm gonna paste a link to the GitHub playbook now. I actually had to re-record part of this, so I won't show cloning the playbook directly, but it should be manageable if you ever downloaded anything from GitHub. All right, carrying on. So to finish setting everything up now, well, we need to make a list of all of the IP addresses that the Raspberry Pis got once they got connected to the network. There's several different ways to achieve this. If you feel comfortable with Nmap, you can point Nmap. You can install that on your Linux distribution or on Windows. It doesn't work on Windows subsystem for Linux, by the way. You have to install the Windows version if you want to use it. But so once you have it, let me show you here. So you can make an invocation like nmap-sn and then your default gateway /24, so it can scan all of the hosts on the /24 segment. So all of the hosts on the subnet, it will try to find if they're alive on your network, and it will show you what they are. As you can see, for example, when I run this, I have a bunch of things come up. Raspberry Pi Foundation, Raspberry Pi, Raspberry Pi, Raspberry Pi. Good stuff, right? So out of all of those nodes, you're going to take one and you're going to decide on it becoming the master node. And all of the rest you can use as workers. Now, full disclaimer before I continue, I've noticed that somehow my board is only reporting 6 machines instead of 7. I'm willing to chalk it up to weirdness with the board or something along those lines. I gotta debug that. But for now, I'm gonna stand up the cluster just with 6 machines instead of 7. Alright, so carrying on. So what we can do now is that. So I already copied all of the IPs here. So you can SSH into them to make sure that they're alive. Default password for this distribution is Hypriot, and default user is Pirate, just because, it's the convention that they had. And I like this distribution, by the way. It looks really cool for ARM. And now, so by default, there's a configuration that we have to override, because Hypriot creates all of the hosts with the same host name. And the cluster doesn't work unless all of the machines in the cluster have different host names. So we're gonna edit sudo by. So we're gonna look for preserve host name and change it to true. All right. Now and edit the host name. So 0.29 is gonna be my master. So I'm gonna do sudo b. All right, now sudo reboot. And I'm gonna do this for every one of the IP addresses that I got, which are 6 of them. Another way to get your IPs, if you want to get at least that you can store somewhere, is that depending on your internet service provider, you may get something different, so your mileage may vary, right? But my provider gives me an access point which has an administrative interface, and I can access it by using the IP of the default gateway directly on a web browser. And I have credentials to this because that's how I roll, because I'm cool like that. Again, not everybody may have access to this, but if you do, this is great. This is a way to just, by default, you can just check out all of the Raspberry Pis that you have on your network. And you can copy the IP addresses that they have from here, right? So I'm gonna change it so all of these come up as different host names. One of them is gonna be called Turing Master, and the rest of them are gonna be Worker 01, Worker 02, Worker 03, and so on and so forth. So jump cut so I can finish editing all of this. The process is the same. SSH into it, remove preserve host name, change the host name, and reboot. Cool. So now, just to verify my setup, check it out. So this is the master node that says Turing Master. All right. Then we have 29. 52 should be one of the workers. All right, carrying on. Just to double check that everything is set up correctly, I'm gonna SSH into every one of the machines, and they should display a unique host name per each. So this is the master node that says Turing Master. Then the other one, that should be worker 1. Yes. Then this should be worker 2. Yes. This should be worker 3. Yes. Then this one should be worker 4. And finally, 216. This should be worker 5. Remember, I got all of this by taking a look at the list of IPs that I got from my access point management interface, but you can also do Nmap, right? All right, so this looks good. So now you have 1, 2, 3, 4, 5, 6 IPs, 6 beautiful IPs that you're gonna enter into the host.ini file. So by default, you should have here beam inventory and then hosts.ini, and enter the IP of the machine that you want to make the master of the cluster under the master configuration, and all of the other IPs should go under node 1, 2, 3, 4, 5. So 5 nodes. This mapping over here, it's fine as it is. You don't need to modify it. And There's also under inventory, there's also a group bars directory, which you can also edit. And here, you're going to have to enter the credentials to access each one of the nodes. I use Ansible user and Ansible password. And these are the default values that you get from the Hypriod OS distribution. But I really encourage you to change that because you shouldn't just be using the default credentials everywhere. All right. So once you have that, now you can do Ansible playbook site.yaml and point it to the host file. And it's going to work its magic. It's going to connect to each one of the nodes, set up the Kubernetes toolchain and resources and all that, and set up the networking so all of these machines can work in tandem. It's going to take a little bit. Should be done within a sec. So this is the moment where if everything goes correct, you should be getting a cold one, ready to spend the rest of your night in having fun and resting because of a job well done. By the way, I love it when things work like this. It just looks so elegant. It just looks like so harmonious. Looks like everything makes sense with the world, man. Everything just clicks. Everything just, yes, it's flowing. It flows. I love this. It's so freaking cool for me to be taking a look at something like this right now. And with this, we're gonna end up with a really freaking awesome cluster. Could you imagine you can actually run a website out of a toaster in your living room? How awesome is that, right? Jeez, man. Well, I mean, of course, if I had a better actual connection to the internet without NAT and without just having a public IP, right? Like on my access point, but still doing its thing. This is so fun. I had a lot of fun with this. Next video, I'm gonna deploy something to actually run on the cluster. For now, I'm just gonna leave up the cluster running. Nice. Nice. All right, so it looks like it finished doing everything that it needed. Play recap, all of this looks great. And so now I need to copy SAP. I'm gonna copy from the master node, this is the IP of that, a configuration which should be on pointcube-config. And I'm gonna copy it to my machine so I can feed it to kubectl. So kubectl is the administration tool for Kubernetes, and you can install it from here, from the Kubernetes website. And all of this should be pretty straightforward. It's literally just copy paste, just curl a couple of URLs and then that's things. I'm not gonna do this for now, but I just wanted to bring it up in case that you need to install it. And let's finish copying this, and then you can set up the kubeconfig environment variable for that. And finally, kubectl get notes. And if all goes well, yes, we have Turing master as the master node, and then we have worker 1, 2, 3, 4, 5 up and running, ready. This, I guess, is a stale record from before. This is the host name that the machine uses to have. I'm not gonna worry about that for now. But yeah, but if you see something like this, then life is good, and it means that your Kubernetes cluster is up and running now. Alright, so I'm thinking that's everything for now. Thanks so much for watching. I'm gonna deploy something to actually run in the cluster next video. For now, I hope that you're staying safe, and I hope that everything is going great for you. See you soon.